Okay. I'm Ritwik, and today I'm gonna revise colloidal state for you. Basically, the chapter మొత్తం definitions ఉంటాయి. This
Recording in progress.
basically colloid is a heterogeneous system in which one substance is dispersed as very fine particles into another substance called dispersion medium. As a very fine particles, that word has a certain boundary. Uh, dispersed particles diameter అన్నది ఒక 10⁻⁹ meters కొద్దిగా ఆ ఆర్డర్ లో ఉంటే దెన్ ఇట్స్ కాల్డ్ కొలైడ్. లేదు ఇఫ్ ఇట్స్ సమ్వాట్ హైయర్ ఆర్డర్ సే 10⁻⁶ or 10⁻³ అప్పుడు వి వోంట్ కాల్ దట్ ఎ కొలైడ్, దట్ వుడ్ బి సమ్వాట్ ఆఫ్ ఏ సస్పెన్షన్. యా 10⁻⁹ నుంచి ఒక 10⁻⁶ దాకా దట్స్ ది పార్టికల్ సైజ్, దెన్ ఇట్స్ ఎ కొలైడ్. Maybe some 10⁻³ to or 10⁻⁶ to 10⁻³ or maybe higher suspension lower than 10⁻⁹, then we're gonna name it like it's called a true solution. Essential difference between a solution and colloid is the particle size. Okay, that's it. Colloidal particles have an enormous surface area because you'll have a lot of particles. It's just the colloidal particles have an enormous surface area based on the logic that amorphous substances have higher surface area than crystalline substances. And Adi, you can figure out by cutting a cube into two. A cube need two pieces can cut cheste. When you cut that into two pieces, two pieces కలిపి ఉన్న surface area is higher than the one piece. So that's the logic. And types of colloids, you have solid, liquid, and all the names are there. Gas in gas is not a colloid. ఎందుకంటే when you try to mix gas with gas, you would form a homogeneous system. Colloids అన్నవి heterogeneous. Like, how do you say this? Gases in gases అన్నవి highly miscible. So you cannot particularly form a colloid. Table is important. Examples for colloid. Types of colloids. Colloids maybe okay, 2 to 3 categories lo differentiate చేస్తారు. One category is this phase, dispersive phase and dispersion medium state బట్టి అదొక type of distinction. ఇంకో type of distinction is lyophobic and lyophilic colloids. This is not said anywhere, but lyophobic and lyophilic are essentially defined for liquid dispersion medium. So vaguely it makes sense like that. So lyophobic కంటే solvent loving, lyophobic కంటే solvent hating, lyophilic కంటే solvent loving. Lyophilic salts are more stable. Lyophilic salts are reversible. Lyophobic salts are reversible. Okay, you can separate out lyophilic salt and మళ్ళీ రెండింటిని కలిపేస్తే you can have the salt formed again. కానీ lyophobic when you break down the salt and try to mix it again, you would not obtain the salt. Lyophilic more stable than lyophobic due to high solvent interactions, basically liquid level. And some examples of lyophilic: gum, gelatin, starch, rubber. Mostly your salt, natural colloids are lyophilic. Yes, okay. An important characteristic of this sol is if the dispersion medium is separate from the dispersed phase. Okay, reversible salts. So that's something. Another distinction is multimolecular, macromolecular, and associated colloids. Associated colloids is micelles. Your multimolecular colloids is your aggregate part, like your dispersed phase particles reach to the size required for a colloid by combining like ఒక 5 to 6 లేదా hundreds of molecules combine అయ్యి కావాల్సినంత size కి వచ్చి and now the whole thing is like one unit of dispersed phase. Aggregation of dispersed phase particles to form a colloid is multimolecular. Layer if the molecules are big enough to single-handedly have a diameter of 10 power minus 9 to 10 power minus 6, then it's called a macromolecular colloid. Your multimolecular colloid example is S8, your macromolecular colloid example is your proteins and other bio, biomolecules. Your man-made macromolecules examples are polythene, nylon, polystyrene, synthetic rubber, essentially polymers. Associated colloids are micelles. These are like, of course, you would know micelles. Low concentration, low, these are multimolecular colloids. High concentration, like, how do you say? Not high concentration, low, these are essentially multimolecular colloids. Low concentration, low, these are partly not colloidal. So let's read this. There are some substances which at low concentrations behave as a normal strong electrolytes, but at higher concentration exhibit colloidal behavior due to formation of aggregates. Yeah, so that's the thing. Concentration పెరిగితే you can have a multimolecular colloid. Otherwise, you would just have a strong electrolyte. And formation of micelles. This is the formation of a soap micelle. This molecule is sodium stearate soap molecule, one of these soap molecules. Soap molecule has two parts, hydrophobic tail and hydrophilic head. Hydrophilic head likes water, phobic hates water. So ఇప్పుడు at low concentration, it's like the first figure. Just ఆ సర్ఫేస్ మీద ఉంటాయి your soap molecules అంతా సర్ఫేస్ మీద ఉండి your head stays in the water, your tail tries to stay out of the water. కానీ ఆఫ్టర్ ఒక కాన్సన్ట్రేషన్ లిమిట్ రీచ్ అయ్యాక యువర్ టైల్ స్టార్ట్ టు గెట్ టుగెదర్. ఎందుకంటే యువర్ హైడ్రోఫోబిక్ కానీ బేసిక్లీ యువర్ హెడ్ ఈస్ హైడ్రోఫీలిక్ బికాస్ ఇట్స్ పోలర్. వాటర్ ఈస్ అ పోలర్ సాల్వెంట్. Like dissolves like logic. Your head is a polar and your water is polar. So your head likes water. Your tail is non-polar. It's a hydrocarbon chain. So it doesn't like water. But hydrocarbons maybe like other hydrocarbons, and since water repels these hydrophobic tails anyways, these tails get together and form that like ring like not exactly ring like substance, form an aggregate of tails and figure లో ఉన్నట్టు ఉంటుంది. Per se it's not a ring, జస్ట్ ఒక పాయింట్ చుట్టూ ది టైల్స్ స్టార్ట్ టు గ్యాదర్ అరౌండ్. బయట హెడ్స్ ఉంటాయి, లోపల టైల్స్ ఉంటాయి. సో ఫ్రమ్ అన్ అవుట్ సైడ్ పాయింట్ ఆఫ్ వ్యూ ఇట్స్ లైక్ పోలార్ స్ఫియర్, కానీ లోపల ఇట్ కంటైన్స్ ది నాన్ పోలార్ పార్ట్. అండ్ దట్ హోల్ యూనిట్ ఈస్ a multimolecular unit, and Since it's kind of special, it's called as micelle. So micelles form at a certain concentration, CMC. CMC varies with pH of solution, temperature of solution, uh, depends on the nature of solvent and dispersion, disperse phase. Application is cleansing action of soaps. Your soap molecule forms micelles with your soap molecule forms micelles with the what do you say dust part, dust of the clothes. Your dust of the clothes contains oil. Oil is non-polar, so your micelles will be formed around the dust particle, and basically a dust and mud అన్నిటిని మూవ్ అయిపోతుంది డస్ట్ పార్టికల్ కలెక్ట్ చేసి essentially your clothes will be clean. Preparation of colloids, highly by hearting stuff. Please read the NCRT for these things. డైరెక్ట్గా ఈ క్వశ్చన్స్ అడుగుతాను. కెమికల్ మెథడ్స్ బేసిక్లీ chemical reactions perform చేస్తే your products can be obtained in the colloidal state. Those are some examples. Electrical disintegration or Bredig-Sark method. This is essentially forming a colloid with high energy. Gold and silver, they, we can also show them as colloids. This jewelry, inka gold biscuits, alane kakunda, can also show them as colloids. Gold salt has a lot of advantages, industrial applications, laboratory applications also. So we need to know the method of preparation of gold salt. That's Bredig-Sark method. Basically, gold ni water lo AC, you electrify the whole solution in that arrangement shown in the figure. Container చుట్టూ కూలింగ్ సిస్టమ్ పెడతారు. In this case, it's ice bath. Electrodes dip చేసి you electrify the whole thing. Gold particles break down into smaller and smaller particles to essentially form a gold salt. Another method, okay, there are some other plenty of methods, but NCERT-లో ఇవే ఉన్నాయి. Purification of colloidal solutions. Colloidal solutions can be impure, disperse phase particles లో impurities ఉండొచ్చు, లేదా how do you say disperse phase particles ఎక్కువ అయిపోయి some of them get precipitated and get stored down, మిగతాదంతా colloid అయిపోద్ది. బట్ precipitate అయినవి దే నీడ్ నాట్ నెసెసరీలీ బి సస్పెండెడ్ డౌన్వర్డ్స్. కొద్దిగా అలాగా సొల్యూషన్ లోనే లైక్ బాటమ్ లోనే కాకుండా సొల్యూషన్ లోనే అలాగా ఫ్లోట్ అవుతూ ఉండొచ్చు. ఇట్ డిపెండ్స్ ఆన్ ద సైజ్. బేసికలీ నీడ్ basically there are lots of types of impurities even in colloids. So colloids need purify చేయడానికి methods mentioned in the NCERT are dialysis, electrodialysis, and these are like for purifying the liquid in solid in liquid colloids. Where colloids ki you're gonna have other methods. These are for solid in liquid colloids. Dialysis and electrodialysis. Electrodialysis is basically a step up of dialysis. Dialysis is the definition. It's a process of removing a dissolved substance from a colloidal solution by means of diffusion through a suitable membrane. So that's the arrangement. ఒక dialyzing bag ఒకటి ఉంటుంది. You're gonna drop the colloid into it. It's like parchment paper, but not exactly parchment paper. Dialyzing membrane కొద్దిగా వేరేలా ఉంటుంది. It essentially colloid వాటర్లోకి వెళ్ళదు, బట్ ది వాటర్ కెన్ ఎంటర్ ది colloid. అలాగా డిజైన్ చేస్తారు డైలైజింగ్ membrane. సో అలాగా బ్యాగ్లో కొలైడ్ వేసి they dip it in water and the water would be running through the colloid. అలాగా ఫ్లో చేస్తూ ఉంటారు. సో యువర్ ఇంప్యూరిటీస్ ఫ్లో అవుట్ విత్ ది impurities flow out with the water. But colloid cannot go through because of the dialyzing membrane. Electrodialysis is essentially the same thing except వాటర్ ఫ్లోకి ఇంకా ఎలక్ట్రిసిటీ యాడ్ చేస్తారు సో దట్ యువర్ ఇంప్యూరిటీ ఇస్ క్లియర్ అవుట్. అంటే ఎలా అంటే యువర్ ఇంప్యూరిటీస్ వుడ్ బ్రేక్ డౌన్. ఓకే, బెటర్ ఎక్స్ప్లెనేషన్. Ordinarily, the process of dialysis is quite slow. It can be made faster by applying an electric field. If we dissolve substance in the impure colloidal solution, is only an electrolyte. So impurity another electrolyte is there. You can use this electrodialysis to speed up the process. Oh yeah, sorry. Yeah. Impurities, electrolytes are impurities in the colloids. ఎందుకంటే electrolytes break down the colloids. ఎందుకు అన్నది you can see that later. Impurities clearly. If you apply an electric field, then just move out the impurity. Electrolytes they come towards the electrodes, essentially more clearing up. Tyndall effect is a property of these colloids. Not only solid in liquid, solid in gas, liquid in gas. Basic colloids అన్నిట్లోనే you can observe Tyndall effect. It is basically how do you say this? Suppose ఒక smoke ఒక చోట గ్యాదర్ అయింది అనుకుంటే when you shoot a laser into the smoke, then laser is supposed to shoot a pinpoint straight line ray, right? And మనం మామూలుగా అయితే ఒక పాయింట్ చూస్తాం బట్ వెన్ యూ సెండ్ ఇట్ త్రూ స్మోక్ ది హోల్ స్మోక్ గెట్స్ ఇల్యూమినేటెడ్. మొత్తం ఆ స్మోక్ అంతా గ్రీన్ కలర్ లో ఫ్లాషింగ్ కనిపిస్తుంది. దట్స్ టిండాల్ ఎఫెక్ట్. హ్యాస్ ఏ లాట్ ఆఫ్ ఎంటర్టైన్మెంట్ అప్లికేషన్స్ అండ్ వెరిఫికేషన్స్ ఆఫ్ కొలాయిడ్స్, ప్యూరిఫికేషన్స్ ఆఫ్ కొలాయిడ్స్, లాట్ ఆఫ్ షిట్ రిలేటెడ్ టు కొలాయిడ్స్. Tyndall effect is observed only when the following two conditions are satisfied. The diameter of dispersed particles is not much smaller than the wavelength of light used, and the diffractive indices of the dispersed phases and dispersion medium differ greatly in magnitude. That seems obvious, right? Why you see Tyndall effect ante your particles are small that they can scatter the light to a greater extent, and when their diffractive indexes differ more, the scattering extent also increases. And the diametric explanation is scattering అవ్వాలంటే your condition is that wavelength of light should be compared to diameter of dispersed particles. Physics on wave optics experiments, your YDSC, Fresnel's prisms, and scattering of light, rainbows. They follow a certain condition, right? Your wavelength of light should be comparative to the slit length or diameter of a particle, the angle of the solid angle of the biprism or something. A parameters key wavelength of light key relation does. See, same thing here. Tyndall effect is used to distinguish between a colloidal and true solution. Sigmund used Tyndall effect to set up an apparatus called as ultra microscope. Basically, yeah, colloidal solutions, so you can observe this scattering of light in a unique fashion. True solutions, so you cannot. Next, another properties of colloids. The color of colloidal solution depends on the light which you're seeing. Basically, say you have a dark room అండ్ ఒక కొలాయిడ్ ఉంది. ఒక కొలాయిడ్ ఒక బీకర్ లో తీసుకుని పెట్టావు, గ్లాస్ ట్రాన్స్పరెంట్ బీకర్. యు ఆర్ షూటింగ్ అనదర్ లేజర్ ఆఫ్ లైట్. ఏదో సమ్ రెడ్ లైట్ ఆర్ గ్రీన్ లైట్ ఏదో షూట్ చేస్తున్నారు. దెన్ యువర్ కొలాయిడ్ వుడ్ సీమ్ రెడ్ ఇన్ ది డైరెక్షన్ ఆఫ్, లైక్ సపోజ్ రెడ్ లైట్ షూట్ చేస్తుంటే then your colloid looks red in the direction of laser. లైక్ లేజర్ ముందుకేసి నువ్వు లేజర్ వెనకాల నుంచి చూస్తుంటే then you can see the రెడ్ కలర్. లేదు, లేజర్ కి ఆపోజిట్ గా చూస్తున్నాం అనుకో, లైక్ సపోజ్ ఇఫ్ యు ఆర్ సీయింగ్ ది ట్రాన్స్మిటెడ్ లైట్, నాట్ ది ఇన్సిడెంట్ లైట్, మొత్తం స్కాటరింగ్ అయిపోయాక రిలీజ్ అయిన ట్రాన్స్మిటింగ్ లైట్ చూస్తే దెన్ మేబీ యూ మైట్ నాట్ అబ్జర్వ్ ది రెడ్ కలర్, మేబీ సమ్ గ్రీన్ ఆర్ బ్లూ కనిపించవచ్చు, డిపెండ్స్ ఆన్ ది colloid size and properties. And colloid's color also depends on the concentration. Gold sol, best example, gold sol. Gold color లో ఉంటుంది కానీ గోల్డ్ సాల్ ఈజ్ ఎసెన్షియల్లీ రెడ్ ఇన్ కలర్. లైక్ మోస్ట్లీ ఇక్కడ గోల్డ్ సాల్ రెడ్ అనే చెప్తారు. ఇట్స్ స్టోర్డ్ ఇన్ ది రెడ్ కాన్సన్ట్రేషన్ లెవెల్. బట్ ఇంకా సాల్ లో ఇంకా ఎక్కువ కాన్సన్ట్రేషన్ పెడితే, లైక్ బిట్వీన్ ది లిమిట్స్ ఇట్స్ వెల్, you can see purple and green colors of gold sol also. Purple, blue, and finally golden. Another property is Brownian moment, essentially movement of from colloidal particles in the medium. Random movement. Brownian moment specialty ఏంటంటే the particle moves in straight lines and suddenly takes turns. It doesn't move in curved paths or something. Particle movement is always in straight line అండ్ అట్లాగా డివియేట్ అవుతా zigzag మోషన్ లో ఉంటుంది. దట్ షోన్ ఇన్ ది పిక్చర్. Reason for Brownian movement is due to unbalanced bombardment of particles by molecules of dispersion medium. The Brownian movement has a stirring effect which does not permit the particles to settle and thus is responsible for the stability of solids. Brownian movement valla there are many applications in the colloidal field, uh, like many applications regarding colloids. One of the applications mentioned in the NCRT is Brownian movement contributes to the stability of colloids. ఎందుకంటే it essentially is to, like the particles during the solution just move అవుతూ ఉంటాయి. They do not come together due to molecular forces because of this Brownian movement. So essentially, your colloid particles won't aggregate and precipitate together. And NCRT లో లేదు, but Brownian movement also explains the relation between the uh, like explains the magnitude of forces between the dispersed phase particles, like ఒక roundabout value completely not required right now. Charge on colloidal particles. Basically, colloidal particles explain చేయడానికి there are lots of theories. One is Helmholtz double layer theory, and మిగతా చాలా theories ఉన్నాయి. Essentially, your colloidal particles can be charged, can be uncharged. If we are talking about charged colloidal particles, there is some theory that should be discussed. Well, I don't think there are uncharged salts, at least నేను ఎప్పుడు చూడలేదు. I only basically positively charged salts, negatively charged salts. Examples, please have a look at them and analyze. Paper easy అంటే that could be a direct question. Okay, colloidal particles always carry an electric charge. That's reasonable. Okay. Colloidal particles always carry an electric charge. There are no neutral colloids. The charge on the solid particles is due to one or more reasons. We due to electron capture by solid particles during electrodispersion of metals, due to preferential absorption of ions from solution and or due to formulation of electrical double layer. So basically multiple ways of acquiring a charge. So multiple colloids. Essentially. So theory regarding the charge particle colloid. I'm gonna explain the example here. When silver nitrate solution is added to potassium iodide. Okay, I'm not gonna explain the example. Basically, say you have a solution of potassium iodide Ki ఉంది. It's like highly polar ionic solvent. ఇప్పుడు దానిలోకి సిల్వర్ నైట్రేట్ వేస్తున్నావు సిల్వర్ నైట్రేట్ ఈస్ లిటిల్ బిట్ కోలెంట్ దెన్ Ki. So when you add AgNO3 into Ki solution, your AgNO3 breaks down and to form AgI and KNO3. KNO3 is ionic, so ions can ఉండిపోద్ది. AgI is sort of a precipitate, but no, ఇలాగ యాడ్ చేస్తున్నావు కాబట్టి what happens is AgI చిన్న చిన్న particles form అయ్యి it would be forming a colloid, and that AgI particles చుట్టూ your I minus particles would be gathering. ఎందుకంటే Ag has Ag plus అని I minus చుట్టూ gather అవుతాయి. So your particles are essentially multimolecular particles in this case, and they are negatively charged. And reverse, if AgNO3 solution లో Ki వేస్తే you're gonna have a positively charged particles ఎందుకంటే మీ AgI చుట్టూ your K plus would be sorry Ag plus would be surrounding. Must be one thing. If FeCl3 is added to excess of hot water, a positively charged salt of hydrated ferric oxide is formed due to absorption of Fe3 plus ions. However, when ferric chloride is added to NaOH, a negatively charged salt is obtained with the absorption of OH minus ions. Same in some lips, same kind of explanation. The common having acquired a like say go to the first example when AgI having I minus surrounded by it. If the I minus is like fixed onto the AgI due to the strong attractions and AgI is like precipitate. But the I minus చుట్టూ your K plus would be revolving obviously. Like I minus అంతా ఒక దగ్గర చేరి it will be like a dense negative charge. So K plus movement అన్నది random ఉండదు. It will be surrounding your I minus also. You're gonna have a K plus layer over the I minus layer. సో ఇట్లాగా టూ AgI చుట్టూ టూ లేయర్స్ క్రియేట్ అవ్వడాన్ని హెల్మ్హోల్ట్జ్ డబుల్ లేయర్ అంటారు. దట్స్ హెల్మ్హోల్ట్జ్ డబుల్ లేయర్ థియరీ ఎసెన్షియల్లీ. And I minus K plus layers మధ్యలో since it's like positive charge and negative charge ఒక potential develop అయింది which essentially contributes to the stability of the particle and the stability of the particle and చుట్టూ లైక్ అన్ని పాజిటివ్ చార్జెస్ లైక్ పై లేయర్ అంతా పాజిటివ్ ఉంది కాబట్టి అదర్ పార్టికల్స్ దేర్ ఆర్ నో ఇంటర్ పార్టికల్ అగ్రిగేషన్స్ రిపెల్లింగ్ అవుతుంది కాబట్టి ఇట్ ఎసెన్షియల్లీ కాంట్రిబ్యూట్స్ టు ది స్టెబిలిటీ ఆఫ్ colloid also. The what I'm trying to say is the the potential difference created between the diffuse layer, topmost layer and inner layer. Topmost layer is called diffuse layer, innermost layer is called fixed layer. Your K plus layer is diffuse layer, I minus layer is fixed layer in the first example case. వాటి మధ్యలో డెవలప్ అయ్యే పొటెన్షియల్ డిఫరెన్స్ వల్ల your it ultimately contributes to the stability of the soil. Not a direct consequence, it's the indirect consequence. So stability of the soil key you can measure like just a potential difference ఎక్కువ ఉంటే you can say more stable, తక్కువ ఉంటే less stable. That potential difference is named as zeta potential. So I took a lot of time for it. The presence of equal and similar charges on colloidal particles is largely responsible in, I just said that. So if you want, కొన్నిసార్లు you won't need colloids, you need to break down the colloids. Colloids unnecessarily form అయ్యే ఛాన్స్ ఉంది, లేదా you wanna extract something from the colloids form. ఇప్పుడు గోల్డ్ సాల్ స్టోర్ చేసావు, ఇఫ్ యూ వన్ హ్యావ్ ది గోల్డ్ సాల్ బ్యాక్ అగైన్ దేర్ ఆర్ సమ్ మెథడ్స్. వన్ ఈస్ electrophorese. That's the arrangement of electrophorese. Basically electrolysis. One second. అలాగా charges పెట్టి they're gonna create a potential, and since the molecules like particles are charged, they go to either cathode or anode depending on the charge. Positively charged particles move towards the cathode while negatively charged particles move towards the anode. When electrophoresis, that is movement of particles in, is prevented by some suitable means, it is observed that the dispersion medium begins to move in an electric field. So essentially మన solution లో voltage apply చేస్తే we would think that solute particles కదా move అయ్యేది అనేసి. So in this case colloid లో voltage apply చేస్తే you would think that the dispersed phase particles would move. But if somehow you could stop the dispersed phase particle movements, then what happens is the dispersion medium itself moves. Basically, we're option is unquote. And when the dispersion medium moves, you're gonna call it as electroosmosis, not electrophoresis. So basically, phoresis aina osmosis aina, your dispersed phase and dispersion medium are gonna get separated, and your colloid is gonna break down. Another thing is coagulation or precipitation. ఇక్కడ you're gonna మనం ఫస్ట్ నుంచి చెప్తా వచ్చింది when your dispersed phase particles get together to form bigger particles than needed for the colloids, then it would like then it's called a precipitate, and precipitate is not it, not harmful for colloid. Precipitate form అయితే your colloid is gonna break down and it's gonna form a suspension. So basically మా dispersed phase particles దగ్గర తేడా ఉన్నది is called precipitation or coagulation. So that's the coagulation of lyophobic salts can be carried out in few ways following this. By electrophoresis, by mixing two oppositely charged colloids. Electrophoresis I already explained. Oppositely charged colloids, essentially positive colloid ni negative colloid ni mix చేస్తే ultimately you're gonna have the interactions whatsoever. ఆ డిఫ్యూజ్ లేయర్ బ్రేక్ అయిపోద్ది, డిఫ్యూజ్ లేయర్ బ్రేక్ అయ్యడం వల్ల ఫిక్స్డ్ లేయర్ బ్రేక్ అయిపోద్ది. మన లోపల ఉండాల్సిన మాలిక్యూల్ ఇట్ వుడ్ బి smaller in size, so it would essentially be a solution. By boiling, so basically when a solid is boiled, the adsorbed layer is disturbed due to increased collisions with the molecules of dispersion medium. This result reduces the charge on the particles and ultimately leads to settling down in the form of a precipitate. Basically, higher kinetic energy, higher collisions, your charge would be lesser. because of the disruptions of diffuse layer. పెద్ద మాలిక్యూల్ కంటే లైక్ పెద్ద సైజ్ పార్టికల్ కంటే చిన్న సైజ్ పార్టికల్ వుడ్ బి స్టేబుల్ ఫర్ హైయర్ కైనటిక్ ఎనర్జీ కొలిజన్స్ అనేసి యువర్ చార్జ్ వుడ్ బి రెడ్యూస్ అండ్ దెన్ ఆల్సో యువర్ కొలైడ్ వుడ్ బి ప్రెజెంట్. తక్కువ చార్జ్ అంటే ఎవరికన్నా తక్కువ జీతా పొందించాలి బై పర్సిస్టెంట్ డయాలసిస్. Dialysis is essentially separating the impurities by the means of size. Parchment paper, that dialyzing membrane kuda can only handle things for an extent. When you do dialysis too much, ఉన్న impurities అన్ని పోయాక the water starts to like వాటర్ ఏమో ఈ మన డిస్పర్స్ ఫేస్ పార్టికల్స్ ని దగ్గర చేయాలని ట్రై చేసింది విత్ ఇన్ ది డయలైజింగ్ మెంబ్రేన్. ఎందుకంటే ఫ్లో ఇస్ వన్ సైడ్ అండ్ అన్ని పార్టికల్స్ అటువైపు పోతా ఉంటాయి. అటువైపు పోతా ఉంటాయి కాబట్టి ఇట్ వుడ్ బి ఈజీ ఫర్ ది పార్టికల్స్ టు అగ్రిగేట్ దెమ్సెల్స్ అండ్ బ్రేక్ అయిపోతుంది మళ్ళీ. బై ఎడిషన్ ఆఫ్ ఎలక్ట్రోలైట్స్, basically electrolyte add చేస్తే your layers would be broken down again. Layers పోయి again your colloid would break down. And addition of electrolytes లో an important point, hence an important question here. It has been observed that generally the greater the valence of flocculating. Okay, this this electrolyte addition method is also called as flocculation. మనం వేసే like say if your sol is positive, like diffuse layer positive ఉంది అప్పుడు అండ్ యువర్ యాడింగ్ KI okay, I'm not remembering. Say your sol is negative maybe and your flocculating agent is KI or AlCl3 or something more ionic, Ali3 maybe అట్లాగా. Your flocculating agent is KIN or Ali3 or MgCl2. These are ionic things, right? అప్పుడు సిన్స్ యువర్ సాల్ ఈస్ నెగిటివ్, flocculating agent లో your only thing that's gonna do the job is the cation. So the cation in this case is the flocculating ion, the one which is gonna neutralize the charge over the colloidal dispersive phase particles. Now, it has been observed that generally the greater the valence of flocculating ion added, greater is its power to cause precipitation. This is known as Hardy-Schulz rule. In the coagulation of a negative sol, the flocculating power is in the order Al plus 3 greater than Ba plus 2 greater than Na plus. Basically, Ali3 ఇంకా MgCl2 వేస్తే your sol is gonna break faster and your sol is gonna break faster in case of Al plus 3. Usually flocculation takes 20 minutes. Like that's the order. Seconds lo kada, hours lo kada, it would take like some tens or 20s of minutes. Al plus 3 to fast ayiddi and effective fast ayiddi. Similarly, the coagulation of a positive sol, the negative ion flocculation. The minimum concentration of an okay, this is important. The minimum concentration of an electrolyte in millimoles per liter is required to cause precipitation of a sol in 2 hours is called coagulating value. The smaller the quantity needed, the higher will be the coagulating power of an ion. Obvious, right? కొద్దిగా వేసిన పని అయిపోతుందంటే your solid, your flocculating agent is so strong that కొద్దిగా వేస్తేనే పని అయిపోతుంది. one molecule of fluctuating agent is able to handle a lot of molecules of dispersed phase. Coagulation of lyophilic salts. Lyophilic salts are stable than lyophobic ఎందుకంటే your lyophilic, you're gonna have your solvent and disperse phase and dispersion medium interactions. Those are, and your lyophobics also, you're gonna have the double layer. And disperse phase and dispersion medium attractions, our bondings are far much greater than your double layer. So it's easy. Breaker to form the break the lyophilic. కానీ lyophilic salts also have charge, and solvation of colloidal particles is essentially the interaction. And interaction they call it as solvation. When these two factors are removed, a lyophilic salt can be coagulated. This is done by adding an electrolyte or and by adding a suitable solvent. So electrolyte is you already know this solvent disperse phase particles charge breaks down and the colloid breaks down. Solvent ఏంటంటే your the other way around. Double layer కాకుండా double layer ని break చేయడం కాకుండా you're gonna reduce the effectiveness of double layer. Zeta potential ఉన్నా కూడా you're gonna make it such that the solvent is not much interacting with your particles. Double layer strength అయిపోద్ది. So your zeta potential, since your zeta potential depends on the disperse phase and dispersion medium combination, తక్కువ zeta potential ఉండే solvent ని యాడ్ చేస్తున్నాం. Maybe like CV example. When solvents such as alcohol or acetone are added to hydrophilic salts, basically hydrophilic are polar, highly polar, and your acetone and alcohol are comparatively less polar. So అప్పుడు the dehydration of dispersed phase occurs under this condition. A small quantity of electrolyte can bring about coagulation. ఒక ట్రిగర్ ఉండాలి. I don't know the reason. Protection of colloids. Lyophilic, you're not gonna need protection unless you break them. You're not gonna need protection. Lyophobic, you're gonna need protections. And how are you gonna do that? You're gonna mix the lyophobic salt with the lyophilic salt. Basically, ఒక lyophilic salt, lyophobic salt, if you're gonna add the lyophilic salt, it is gonna protect the lyophobic colloid. ఎలాగంటే the lyophilic particles form a layer around the lyophobic particles and thus protect the layer from electrolytes. చుట్టూ ఒక లేయర్ ఫామ్ చేస్తుంది కాబట్టి lyophilic salts are not gonna get disturbed. Emulsions, two types: oil in water, water in oil. Dispersion medium, water, disperse phase water, oil అయితే it's oil in water. It's straight. Emulsions of oil and water are unstable and sometimes they separate into two layers on standing. For stabilization of an emulsion, a third component called emulsifying agent is added. The emulsifying agent forms an interfacial film between the suspended particles and the medium. Essentially, like adding a lyophilic salt to a lyophobic salt. The principal emulsifying agents for oil and water emulsions are proteins, gums, and natural and synthetic soaps. Basically, non-polar things. And for water in oil, heavy metal salts of fatty acids, long chain alcohols, lamp black. So relatively more polar, more charged things. Emulsions can be diluted with any amount of dispersion medium. On the other hand, the dispersed liquid, when mixed, forms a separate layer Basically, dispersion medium ఎంత ఉండొచ్చు కానీ dispersed phase అంత ఉండకూడదు. Dispersed phase ఎక్కువ అయితే your emulsion is gonna break down. The droplets in emulsions are often negatively charged and can be precipitated by electrolytes. This is also important. They also show Brownian moment and Kendall effect like other colloids. Emulsions can be broken down into constituent liquids by heating, freezing, centrifuging, or by removing the emulsifying agent by adding another electrolyte or no, not an electrolyte. You can remove the emulsifying agent in some ways also, but these are easy because heating, freezing, and centrifuging. Basically, your breakdown cotton candy thing, I guess, is breakdown of emulsion. Your formation of cheese by centrifuging is also formation of cheese or butter or some dairy products. They're gonna centrifuge the milk with curd mixture, and that is breakdown of emulsion of water emulsion. Sorry, milk emulsion. We say, ah, centrifuging the milk is forms use the cheese, and that's an application. That's proof that centrifuging breaks the colloid. Colloids around us, please refer to the examples. Blue color of sky is due to dust particles in air, uh, fog, mist, rain, water particles in air, food articles, your milk, butter, halwa. Some of the fluid articles are colloids. Your blood is a colloid of, what do you say? Colloid of an albuminoid substance. I don't remember. What is this? The styptic action of aluminum ferric chloride solution is due to the coagulation of blood forming a clot which stops further bleeding. Your soils are colloids. Your formation of delta is also a colloid phenomenon. River water is a colloidal solution of clay. Seawater contains a number of electrolytes. When river water meets seawater, your colloid is gonna break in the deposition of the clay at that junction of seawater and river water forms a delta. Other applications of colloids, electrical precipitation of smoke. Smoke is a colloid, and you're gonna break that down by applying electricity through that certain arrangement. Smoke వస్తుంటే you're gonna send a pass it through a high voltage in the smoke. This breaks down and doesn't leave the atmosphere. Doesn't leave into atmosphere. Smoke అన్నది బయటకు వదిలితే your atmosphere is gonna get polluted. So you can just use this cotton smoke precipitator. Uh, Purification of drinking water, that's obviously your RO filters and all are this application. Medicines, your medicinal phenomena is a matter of colloids. Your enzymes are colloids. So your enzyme study is a study of medicine. Your medicines is a study of enzymes, and your enzymes are colloids. So medicines, I guess. Actually, this is important. అక్కడ ఇచ్చిన చదవండి కొలాయిడల్ యాంటిమోనీ is used in curing cancer. Colloidal gold is used for intramuscular injection. So what here they're trying to say is you can use certain colloids as medicines also. అక్కడ ఏ colloids ఇచ్చారు ప్లీజ్ రిఫర్ టు దట్. Tanning, not exactly necessary, but I'm gonna explain. Animal hides are also colloidal in nature. When a hide which has a positively charged particle is soaked in tannin, which contains the negatively charged colloidal particles, mutual cooperation takes place. This is the formation of your leather and similar like fashion products from animals. Your leather or fur of some muppets వీటిని ప్యూరిఫై చేసేటప్పుడు అండ్ వీటిని టైం చేసేటప్పుడు యూఆర్ గonna యూస్ దిస్ కొలైడల్ కాన్సెప్ట్స్. This is also important. I never saw a question, but this is also important. Cleansing action of soaps and detergents, your micelles theory. Photographic plates and films. See, is also these all are quite important. Your photographic plates and films are prepared by coating an emulsion of light sensitive silver bromide in gelatin over glass plates or celluloid films. I don't know how that works either, but that's important. Your silver bromide is light sensitive, and almost every camera in the old times use this method. They're gonna take a picture, and a picture ni they're gonna dip it in the solutions. Appudu you're gonna have a photo that is made possible by AGBR. AGBR reacts to like ఇప్పుడు certain type frequencies of light పడితే AGBR reacts differently. Okay, implementations ni you can store them using AGBR light frequency implementations. Yeah, rubber and last minute, I think. Your latex is also colloid. Your breakdown of latex to form natural rubber is an application. Industrial products, a lot of industrial products are prepared. They are colloids, so their study of preparation is necessary. So, so I couldn't solve the previous year questions. So thank you. We are done.